Hi everyone. In this lecture, I will talk about some of the ways in which the human mind works when we're reasoning and thinking. And then I'll also be talking about some of the common mistakes or pitfalls that arise from that way in which our mind is set up. So let me now switch to my slides. Okay, so this course is about reasoning. And in a couple of weeks, we're going to introduce certain formal tools from logic and mathematics that will help us capture reasoning and get a precise grip on how reasoning works. But before introducing that formalism, and over the next couple of weeks, we will look at the following. We're going to be talking about how to recognize good and bad reasoning, why we often fail to reason well, and how we can do better. So the various types of reasoning in this class we'll be discussing are as follows. First, deductive reasoning. Second, probabilistic reasoning or inductive reasoning. And finally, decision theoretic reasoning or making decisions or deliberation. Okay, now whether you want to consider decision theoretic reasoning as a kind of reasoning or as something else, decision making. So the title of this course, for instance, is Introduction to Formal Reasoning and Decision Making. So whether you want to consider decision making to be a type of reasoning or not, that doesn't really matter. What matters is that throughout this course, these are the three things that we'll be talking about. And before we dive into the formal theories of these things, we're going to be getting a grip, uh, a more solid intuitive grip on what they are and how we can be better at them. So here are some things we'll be talking about and things that when you take this course, you'll learn. So you're going to learn about ways in which we are irrational or, reason badly, but which are predictable or inevitable that arise from how our minds are actually set up. So it's important for us to recognize these predictable ways in which we act irrationally. Then we'll also be talking about more theoretical um, issues or fallacies in reasoning, and we'll be learning about how to use logic in order to uh, understand why those are fallacies. Okay, and then we'll also be looking at how probability and decisions work. Okay, so these um, things that you'll learn will make you much smarter, as you can see from the pictures of the brain, and that's your brain. And then after you take this class, you will have the galaxy brain. But so that's kind of the overall plan for the course and which gives some context for what we're doing right now. Okay, but right now in this lecture, um, what we're gonna I'm gonna help you understand the following things in particular. What you're going to understand is that there's two different systems or two different ways in which our minds go about solving problems or reasoning. And these two ways are called System 1 and System 2. And so you're going to learn we're going to be talking about a bit of cognitive science in terms of two different systems that our mind employs. Okay, and explaining these will be able to show us the basis of certain ways in which we're misled or do poorly on certain tasks because of the way those systems are set up. So in this video, I'm mainly going to be focusing on explaining to you what these two systems are. And in the next video, which makes up this lecture, we'll be talking about certain cognitive illusions and uh, that arise from these systems. Okay. So this picture here should make you feel a certain way when you see it. Okay. And the idea is that when you see this, you immediately maybe are disturbed because there's someone who is angry. Okay, and this person looks like they're about to say nasty things or yell at you or be aggressive. Okay, and this kind of gut reaction which you got from looking at this picture was exactly that, a very quick gut reaction. So you just saw this image and immediately you're probably were a bit unnerved or maybe afraid or just had a negative reaction to seeing this. And because you're immediately able to tell that this person is angry and possibly yelling or saying um, mean things, okay? And it's not as if when you saw this picture you intended or made a conscious decision to assess the mood or to assess what was happening. It just was a very quick reaction. Okay, so so the question is, how is it that you've come to have such a quick assessment or reaction to an image like this? Okay, now look at this picture, not of a human, but of a bonobo monkey. When you look at the face of this one here, we get an immediate sense of joy or happiness. Okay, so when you look at this face, it probably looks cute. It's definitely much cuter than the last face. And you can tell, and you kind of immediately get a sense of, from the facial expression, about kind of what's emotionally happening with this creature. Okay, and again, this assessment or this kind of reasoning, in a sense, of how this creature is feeling happened in a very, very quick way. You look at this kind of smile and you kind of get an immediate sense of what's happening inside this creature's head. Okay. Now consider the following, I guess, math problem, and which is, what does 18 times 26 equal? Okay. Now, in the last two slides, you saw two pictures of faces and were able to immediately come to understand or assess the emotional feelings of those people or the monkey. In this case, when you see this equation and you're asked how to finish the equation, what 18 times 26 is, you're not able to have a quick response. Okay, so here we cannot easily reason, not very quickly and immediately reason to find the answer. It takes us effort. Okay, so you can, I'm sure, get a vague sense of what the answer would be. So like, maybe it's around the few hundreds, obviously it's not 10,000 or more, right? It's obviously much more than 100. Okay, but to actually find the answer requires work. So you could use pencil and paper, okay, or you could think really hard and use certain techniques in your head, okay, but the point is that to find the answer to this is not quick and immediate in the way that telling the emotions of people or apes is. Okay, so just very briefly, so here what we've looked at are two kinds of things that we do in our mind. So one is we very quickly determine the emotions of creatures and people based on their face. And another thing we do is, solve some more complex math questions. Okay, so the idea is that in each of these two different tasks, there's a different system in operation. Okay, so system one is the one that has to do with very quick, immediate tasks like facial recognition. Okay, and that system one is taking place mostly in the limbic system, which is a more older part of the brain. And whereas for the more sophisticated tasks, like for example, solving this math problem, that is performed by system two. And system two, its activity takes place in the frontal lobe. So these two systems, which we have seen the effects of in these two different types of cases, are again system one and system two. So in general, system one is automatic and quick, and it involves little or no effort on your behalf and it's also involuntary. It just happens. System 2, on the other hand, is conscious and deliberate and effortful, and it involves agency. So it involves what you do, what you decide to do, what you consciously do and understand yourself as choosing to do, and choice, and requires concentration. Okay. So here are some tasks that System 1 is predominantly used for. So first, it can be used to judge one object as more distant than another. So when you look around, you are able to very immediately tell kind of the relative locations of the things around you. Or it can be used to orient to the source of a noise, to complete linguistic phrases that you're familiar with, um, to feel disgust in response to a smell, and this is something that we'll look at in a bit more detail in a moment, or drive, especially when driving has no serious challenges to it. So if it's just an empty road, then you can just kind of go on autopilot, so to speak, and just you don't have to really think about what you're doing. Okay, and also related to the facial recognition that we saw earlier, there's also kind of other reactions to people that are very quick and automatic. So it can lead to stereotyping. System 2, which is a more effortful, conscious, sophisticated system. Here are some applications of it. So for instance, you're in a race and you're waiting for the race to start. So the starter gun will go off and you'll have to start running as fast as you can. And you kind of, when you're waiting for that, you're set up in a certain position and you're consciously attending and waiting for the gun to start, and it's taking up all of your conscious attention. Let's say you're talking to a friend about your book, and you're trying to remember who wrote the book you're talking about. In some cases, it can be automatic, okay, but in other cases, it requires you to consciously search your memory, and it can take quite a long time. Okay. And this kind of highlights a point that whether System 1 or System 2 is used in a task is not a simple all or nothing affair. There's many tasks, are basically all tasks in which there's a mix of the two systems, okay? And it might be the case that a certain task is at one time used by System 1 and another time solved by System 2. But what is the case is that certain types of tasks are more generally the domain of one of the systems. Okay, so these are tasks that are canonically or paradigmatically solved by certain systems, but again, it's not an all or nothing affair. So a couple more examples is when you file your taxes, or when you're comparing two prices, which is a kind of sophisticated mathematical problem. So it requires conscious effort and attention. So System 1 again is very fast. Okay, cognitively it involves very specialized modules, and that's not something we have to get into the details of. Okay, and this is the kind of the reason that it's very fast. Okay, and involves these kind of specialized cognitive modules is a kind of strength of it, because that means that we're able to solve certain problems very quickly. Okay, and so now let's look at an example of why this is a strength. Okay, so I want you to look at these two sets of pictures, so on the left and the right. Okay, so when you look at these two pictures here, so this here is some kind of, it looks like a very clean and clear substance, and this is a person who looks pretty normal. So when you look at these pictures, you don't really feel much. Maybe you wonder what this liquid is. But when you look at these pictures, the idea is that you get a very immediate feeling of disgust. Okay, so this whatever this liquid here just looks gross. Okay, and in this case, this man's face also looks pretty gross and repellent. Okay, no offense to him, but the point is that when your System 1, when you see these pictures, kind of quickly generates an immediate feeling of disgust, okay? And what this does is it helps you survive in the sense that it helps you kind of identify what potentially has a disease or could be harmful to you. Okay, so here this is an example of system one that working in its very fast way to help you avoid risk. And so this example of avoiding disease is very relevant to the current day, okay, where obviously when we're walking around in public spaces, we're much more concerned about the spread of disease, okay? So here's another two sets of pictures. So the idea is that when you see these pictures, and these numbers mean that they ran these pictures on tests, and they showed with many subjects that these pictures did not elicit feelings of disgust, okay? But when you look at this, you're more, immediately kind of repelled or hesitant or kind of wary of it because these things just seem gross and unsafe, and that's kind of reflecting how we have this kind of aspect of our cognition that works very quickly to kind of make us move away or avoid things that might be potentially dangerous. For instance, us getting a disease. Okay, and that is a kind of a strength of system one, which is that it very quickly tells us how to react. Okay, but so there are undeniably certain strengths of system one, but at the same time, those strengths also lead to weaknesses. Okay, so because system one is very fast, it's often using what are called heuristics or shortcuts. Okay, so for instance, maybe might be the yellow color of this liquid is what system one is basing, or like the fact that there's kind of yellowish and reddish colors is kind of a heuristic for something to be gross. Okay, and similarly here versus the color of the liquid. Okay, so system one in many cases uses shortcuts to arrive at its conclusions. But because it's using shortcuts and very quickly trying to solve these problems, it's subject to biases or systematic biases. Okay, and we'll see some examples of that in a moment. Okay, so just as we were discussing a moment ago, how our feeling of disgust is a result of system one, and how that kind of tracks in a reasonably good way how we can avoid disease, okay? What that kind of indicates is that the system one, these kind of basic feelings of disgust that are generated when we look around at various things, this has its basis in prehistory or evolution, okay? And so its operation has certain characteristics that are carried over from our more ancient times when they evolved evolutionarily. Okay, and these are called vestigial characteristics. Okay, so another example is I want you to think about why it is that we get goosebumps. Why is it that when we're cold or afraid, why is it that we get goosebumps? Okay, so just take 1 moment before I move on and to think about the following question, which is again, when we are cold or when we're afraid, we have this immediate reaction in which we get goosebumps and our hair stands on end. And if you think of this as a kind of system one in operation to very quickly and immediately provide a certain reaction, why might this be the case? So the answer is that we get goosebumps to make our hair stand on end. Okay, so I obviously don't know the details of the biology, but the goosebumps here make the hair on our body stand up straight, as in this picture. And what this does is it helps with the cold because having our hair setting on end, I guess, will help make us warmer. Okay, but it also makes us look bigger. Okay, and so it makes us look kind of scarier. So I mean, cats are very cute, but this cat definitely looks a bit scary. So this hair is kind of setting an end to make it look, I guess, make it look bigger and more intimidating. Similarly here. Okay, so that's kind of what the evolutionary function of goosebumps is. It makes us warmer, makes us look bigger and more scarier. Okay, um, and this also happens in humans, but the thing is, because we no longer, or because we don't have full coats of hair, clearly this isn't doing much for us. Okay, when our hair stands on end, it doesn't really make us look much different. Okay, and furthermore, we have uh, invented clothing like we can wear a thick coat in the winter to look warm. Okay, um, so the system of goosebumps for us what kind of is carried over from a long time ago when we had maybe had more hair and it was kind of necessary we didn't have the same kind of warm clothes. Okay, um, but nonetheless, even though those times are long gone, this kind of system one operation is still going strong. Okay, so so again, the effect of goosebumps when we're afraid or when we're cold is you can think of it as one of these kind of quick automatic processes that correspond to system one. And you can understand when you think about the evolutionary history, you can understand why it has a certain purpose. But in this case and many others, that purpose is no longer super relevant, but it still happens. And we don't really control it. It's involuntary. So just like the example we just looked at, here are some other functions of system one that are out of place in our contemporary environment. So it's natural to have a kind of fear of heights. Okay. Um, and so what that means is that when we take an airplane, many people feel very, very afraid. Or if you're on top of a very high tower or building, right, and looking down, you feel very afraid, even though there's really basically no chance that you will actually be um, actually hurt. Okay, but you still feel afraid because of this kind of general fear of heights. Just skip to the last one. Um, I guess in our enlightened society, it's no longer as important to uh, have to establish your rank, though obviously to an extent it is, right? But you can imagine maybe in far in the past, you had to much more kind of fight to establish your kind of dominance within your kind of small tribe or something. And these kind of feelings of anger or machismo, I probably mispronounced that, but those are these kind of system one, these kind of very basic things we feel that played a role in the past, played a very important role in the past, but no longer do, or are out of place. So in terms of fear, it's very natural to have, for instance, a fear of snakes and spiders. Okay, and these are in a sense innate. Uh, so infants, very, very young, feel this kind of fear of these things. Uh, and so it's plausibly it's not learned, okay? It's just this kind of basic system one reaction that presumably has developed in order to help us survive. So there's many kind of very dangerous spiders and very poisonous spiders and very poisonous snakes, okay? And that's why we've kind of developed this innate kind of response of fear. And then so here's uh, the example of fear of heights. Okay, so even just looking, for instance, I'm very afraid of heights, and even just looking at this picture on the right makes me afraid, even though I'm sitting comfortably in my room. Okay, so again, these are just kind of these are system one, very quick, immediate reactions that serve some purpose, but because they're very quick and immediate, there's many cases in which we feel their effects when they're not actually relevant. Okay, so the things we're talking about now, we're not going to be in terms of fear of snakes or fear of heights, okay, or the evolution of like goosebumps or whatever. We're not going to be diving in any detail to that in this class, okay? What these things are trying to do is illustrate a certain way in which our mind works, uh, in which it works very quickly, okay, and uses shortcuts or heuristics, okay. And now that we've gotten that idea on the table, we can start talking about certain illusions. And so I'm going to talk about some visual illusions, okay. And then after we understand how visual illusions are generated from this kind of system one behavior, what we are then going to be looking at cognitive illusions. And we'll actually see, not just in the next 2 weeks, but throughout this course as well, we're going to be talking about certain cognitive illusions. Or another way of putting that is bad reasoning. Okay, so cases in which we reason badly. And we'll be able and understanding the way that system one works will actually help us shed some light on what bad reasoning is, or what these cognitive illusions are. And we'll be able to understand more clearly how they arise and how to combat them. Okay, so I'm gonna finish this video with an example of a visual illusion. Okay, so the long side of the left table appears longer than the long side of the right table. So if you just look at these two tables, it'll seem that this line here is longer than this line. However, these two lines are of equal length. Okay. So what you can do is you could take a ruler to the screen if you really wanted. And you'd see that these are equal length, okay? So this impression of difference of length is generated from how it is that our system, our visual system, in a very primitive way, in terms of it very quickly, very quickly processing the things we see, the way it determines the relative orientation of objects, okay, and shapes. So this kind of method in which the visual system very quickly kind of paints or creates an understanding of reality works via system one, and in this case, the methods it uses generates a mistake. Okay, and that mistake is in it seeming to us that this line is longer than this line. Okay, and what's really important to note about this visual illusion, and which also applies to all other visual illusions, is that even when you're told or you recognize for yourself in your thought, in your conscious thought, once you realize that these are actually the same length, that doesn't change the fact that they still look to be different lengths. So just because in your system two, in your more reflective mind, you realize that these two things are the same length, it doesn't change the fact that your other system, the system one, is making them seem different, okay? So it's actually very difficult to overcome these illusions. You have to consciously realize that you're being misled, okay? And you have to keep that constantly in mind, or else you'll become misled again, okay? And that's because the effective system one is kind of autonomous, or is kind of not under the direct control of system two. So you can't just consciously reach into the way that your visual system works and decide that it's going to start making these two lines look the same way. Okay. And when we start looking at reasoning and thinking, we'll see some analogies of this kind of visual illusion. And understanding the analogy with the visual illusion will help us identify and overcome the cognitive illusions better. Okay, so in summary, visual illusions involve a conflict between the system one and system two. We have to consciously override the impressions that system one gives us But still, even when we override those or realize those, they don't go away, they persist because we don't have direct control over system one. Okay, and now when we think about cognitive illusions, we want to identify them, and now we're going to think about, can they be overcome and how they can. Okay, and again, it's very difficult to override system one. In the visual case, it's basically impossible. Okay, and unless you were basically told that these are different lengths by me, you probably wouldn't realize it. Okay, so the errors that are happening are very difficult to detect. Okay, and also our conscious system two is often very lazy. It doesn't bother trying to work that hard to try to figure out those errors. Okay, that's why when someone discovers a visual illusion, is very interesting. Okay, and usually our system two is actually very lazy and just kind of takes the deliverances of system one and says, yes, just kind of takes them for granted. Okay, and when we start looking at cognitive illusions and reasoning, we're going to rethink about how we can stop ourselves from being misled.